Very good morning to everyone. Today we are starting with some basic principles and techniques in organic chemistry. The first lecture about basic concepts of carbon and IUPAC nomenclature. Today's topic: basic concepts of carbon and IUPAC nomenclature. Right. That we would take about every carbon compound or organic compound most widely distributed with carbon. Carbon is the essential element because then either before according to vital force theory or after vital force theory, all organic compounds contain carbon as the essential element. And that carbon, it always show tetravalency, high catenation power, and multiple bond or else a single bond, double bond or triple bond formation capacity. Such kind of properties as enhanced lot of organic compounds in excited state of carbon. Therefore, if carbon is the element, carbon surrounded by all four single bonds show sp3 hybridization. Carbon surrounded by all four single bonds shows sp3 hybridization. Carbon with one double bond shows sp2 hybridization. Carbon either with two double bonds or one triple bond, it shows sp hybridization. Then on the carbon center itself, number of hybrid orbitals, if it is undergoing sp3 hybridization, we can identify four hybrid and no unhybridized, that is pure orbitals are absent on carbon center. And number of pure orbitals also equal to number of hydrogens. In such a way, carbon with one double bond show sp2, three hybrid and one pure out of four orbitals present on carbon center. Then either two double bonds or one triple bond show two hybrid and two pure orbitals, and again remaining number of hydrogens is equal to number of pure orbitals. And therefore, for example, when we take benzene is an example, benzene it contains every carbon shows one double bond. Therefore, hybrid is equal to total 6 carbons, 6 into 3, 18. On every carbon center, one pure orbital exists. Therefore, 6 carbon, 6 hybrid, and number of hydrogens are there 6. Therefore, 6 into 1 plus 6 is equal to 12 pure or unhybridized orbitals exist. Hybrid is to pure means 18 is to 12 or 3 is to 2, or purist hybrid show that is 12 is to 18 or 2 is to 3. So therefore, hybrid and pure orbitals we can calculate in this specific manner. Then next point we would take, what do you mean, what is double bond equivalence or degree of unsaturation? Both are same. Double bond equivalent, DBE means double bond equivalence, DU means degree of unsaturation. If you take this topic, double bond equivalence means how many double bonds are there. Its equivalent what we would take. Double bond equivalence is equal to number of double bonds plus number of cyclic groups. One cyclic group is equal to one double bond. And number of triple bonds is equal to twice the number of double bond equivalents. If that is the situation, for example, when we take one triple bond, one double bond, two double bonds are there in the given compound, so one double bond is equal to, double bond equivalent means two for double bond we can take, one for double bond and another one for another double bond. Total double bond equivalents we would get 4. In such a way, benzene when we take, here double bonds are there 3, therefore 3, one cyclic group 1, total double bonds are degree of unsaturation, or else when compared to alkanes, unsaturation we would observe 4 times. That is, degree of unsaturation or double bond equivalence we would take 4. Like that we can calculate. That is second point you have to keep in your mind. Like that, any examples, triple bond is there, twice you have to take, double bond is there equivalent to number of double bonds, number of cyclic groups also equal to number of double bonds. That is the concept about double bond equivalence. Third point we would take about aromaticity. Aromaticity, it shows stability of molecule. Aromatic compounds are more stable, anti-aromatic compounds are least stable. Non-aromatic compounds are there between aromatic as well as anti-aromatic. So therefore, aromaticity we can explain by using Huckel's rule, that is 4n plus 2 pi electrons, and every carbon should be there in the planar shape. as well as third point we can take delocalization of pi electrons. If there is no delocalization, no aromaticity, even though they satisfy 4n plus 2 pi electron system. Suppose when we take benzene, then all bond lengths are equal. CC bond length in double bond or single bond, because of delocalization of pi electrons, all bond lengths are equal. Then that is equal to how much we would take 1.39 or 139 angstrom units or else 139 picometers. And whereas in naphthalene, when we take, suppose if you take 1, 2, that is double bond. This is 3. 1, 2 double bond length is 1.36 angstrom units, but in 2, 3 bond, it gives 1.40 angstrom units, because perfect delocalization we cannot observe in naphthalene. Like benzene, it is a perfect delocalization take place, but it is also undergo delocalization. It is not that much speed. Double bond length and single bond length slightly dissimilar their bond lengths. Therefore, but here 6 pi electrons are there. 3 double bond show 6 pi. 6 pi satisfied with if n is equal to 1, 6 pi electrons, therefore aromatic. Benzene is aromatic. In the same way, naphthalene, it contains 5 double bonds, that is equal to 10 pi electrons. 10 pi electrons we can observe by the satisfying, that is 2, n is equal to, n is an integer, n is equal to 2 if you keep 2, 4 to the 8 plus 2, 10 pi electrons we would get. Therefore, 10 pi electrons, all carbons are planar carbons. Therefore, naphthalene also give aromatic nature. Therefore, in such a way, then their followers are benzenides or non-benzenides. If they satisfy these 3 conditions, then definitely benzenides mean benzene following compounds. Non-benzenides means they cannot show the structure of benzene. Therefore, all those compounds, if they satisfy these 3 points, definitely all those are aromatic compounds we can give. Aromaticity show more stability of organic compound. Then anti-aromatic, least stability based on the number of pi electrons we can give. Suppose when we take 4 pi electron system, that is cyclo-1,3-butadiene, then if it is there, 2 pi bonds are there, that is equal to 4 pi electrons. 4 pi electrons satisfy, n is equal to 1 means 4 pi electrons anti-aromatic. Anti-aromatic shows more reactive or least stability. Then non-aromatic third type, if the compound satisfy 4n plus 2 pi electrons or 4n pi electrons, 4n plus 2 pi or 4n pi electrons with the non-planar carbons. Non-planar carbon is there, it gives always non-aromatic nature. Non-aromatic compound stability we would observe between aromatic as well as anti-aromatic. So therefore, non-planar carbon, suppose if you take cyclopropadienol, then here we would observe one pi bond, another one is their negative charge. Then it is equivalent to 4 pi electrons because of delocalization of this negative charge. 4 pi electrons, then these 4 pi electrons with the non-planar carbon. What is this? Non-planar carbon. Non-planar carbon, it shows non-aromatic. Then cycloheptadienyl carbanion. Here we would observe total 1, 2, 3, 6 pi plus 2, 8 pi electrons. But 8 pi electrons, it is not an anti-aromatic, but it is non-aromatic due to the non-planar carbon present in this compound. Non-planarity show little bit stability is lesser than aromatic compounds. Therefore, such this kind of benzenides, these are non-benzenide compounds. Therefore, those non-benzenide or benzenide compounds, if they satisfy non-planar carbons show they are called non-aromatic compounds. That is a third concept we would learn from this. Then next fourth concept we would take, that is IU, that is carbon with the primary, secondary, tertiary carbons and IUPAC nomenclature. Now, we would take about a common system of organic compounds. Then here carbon with carbon attaches with one carbon, it shows primary carbon, and carbon attaches with 2 carbons, show secondary. Therefore, these 2 carbons, they attaches with only 1 carbon, then they are called primary carbons. Suppose if you take carbon attaches with 2 carbons, therefore 2 carbons indicate this is secondary, these 2 carbons are primary carbons. Suppose carbon attaches with 3 carbons. Another one may be there hydrogen or any other element. But this carbon, we would take it as tertiary, and these 3 carbons are called primary carbons. Carbon surrounded by 4 carbons. Then these 4 carbons are called primary carbons, and middle carbon we can take it as the quaternary carbon. So therefore, quaternary carbon we would take carbon surrounded by 4 carbons. Then in the same model, then there we would observe this is the basic idea about primary, secondary, and tertiary. Then in the same way, suppose any carbon extends its structure. Any carbon attaches with 2 methyl groups, extend with its structure, then this part we can take as iso group. What do you say? Iso group. Then in the same way, then this iso group we can identify in the same model. Then suppose carbon surrounded by 4 carbons. Then this is called a neocarbon. Then isocarbon, neocarbon. Tertiary carbon means carbon attaches with 3 carbon, then it is also called tertiary carbon. Neocarbon means carbon surrounded with 4 carbon. One carbon attaches with 2 methyl groups and extension may be any length, then it is called iso group. But if carbon attaches with 2 ethyl groups and extension is there, we cannot say this is iso group. Only 2 methyls extension of any length of organic compound show iso group. So therefore, this is basic idea about primary, secondary, tertiary, as well as iso, neo, and tertiary carbons. We would learn from this, and that is about basic ideas or some basics on the carbon elements. Then suppose bond line formula. Suppose if you take this is called ethane, we can write then every carbon with hydrogens, wherever carbon is there, end carbon exists, any corners are there, carbon exists. Double bond is there, turning required, triple bond do not require any turnings because of carbon shows in triple bond linear shape. Therefore, then here we would observe it is bond line formula of ethane we can take like this. Suppose if the compound is there in this specific manner, that is propane, then we can write in bond line formula 1, 2, 3 carbons with the total hydrogens we can show. Then if the compound is there in this way, then it is called propene, then we can write 1 double bond with 3 carbons. So therefore, this is the about bond line formula. Wherever, even though when we cannot show hydrogens, hydrogens exist with 1 carbon, therefore either ending or turnings always exist this kind of carbons. Suppose if the compound exists in this way, then we can draw, we should not bend the carbon, but we can write in this way, here carbon, carbon, carbon. 3 carbons exist and with hydrogen, but we should not bend any triple bond. Then like this, we can observe bond line formula in the organic compounds. Then next, let me would take, that is about bond line formula of organic compounds. Then how many secondary hydrogens are there? How many tertiary hydrogens are there? How many primary hydrogens are there? We can, if the number of hydrogen depends on number of primary, secondary, and tertiary carbon. Primary carbon, how many hydrogens are there? Secondary carbon, how many hydrogens are there? Tertiary carbon, how many hydrogens are there? That depends on the carbon, type of carbon, and shows number of primary, secondary, and tertiary hydrogens we would observe. Then that is about idea on that. Next, let me would take about IUPAC nomenclature. Suppose when we come across to International Union of Pure and Applied Chemists or Chemistry nomenclature that is accepted, language may be Kannada or Telugu or German or French, but nomenclature of organic compound universally same we have to do. That is called IUPAC nomenclature. Because of understanding of every compound, then we will go with IUPAC nomenclature. in that we would go with syntax. We would take it as a prefix, maybe primary or secondary, then word root plus suffix. This is the syntax name we would follow for giving of any organic compound. Word root shows number of carbons. 1 carbon with, 2 carbons with, 3 carbons plus, 4 carbons with, 5 carbons spent, 6 carbons set, 7 carbons set, 8 carbons here, after 9 carbons known, 10 carbons dead, like that it has been go on extend more number of carbons. Suffix it shows primary as well as secondary. Primary suffix show saturation or unsaturation. Saturation show all in, double bond shows, double and triple bond show unsaturation, double bond denoted with in, triple bond denoted with I. Prefixes are their numerals like 1, 2, 3, and functional group also we can show. Secondary suffixes also show functional group, then that functional group should be there in the word root name at the end. So multifunctional groups, when we take highest priority functional group, we should take in the long chain name, and remaining all functional groups comes under prefix. So that is brief idea about nomenclature. Suppose if you take any organic compound, suppose more than one substituent or more than one groups are there on the compound, then we should follow. Then if always this word root or else syntax we cannot follow, because of numbering is essential, from which direction we can give that numbering. So therefore, that direction purpose, we need always some basic rules. First rule we can take the longest chain rule. So we have to select the longest chain with the less complexity, or less number of substituents should be there. Sorry, more number of substituents should be there on the longest chain. Like that, we can select the longest chain. Then second point, the least sum rule. Then number of substituents by the addition from either from right or left. Suppose when we take the compound is there in this way, that is bond line formula. Then if it is a given compound, then if it is the given compound, we can go with numbering 1, 2, 3, 4, 5, 6, 7. But we should not give from this side, because of other than longest chain, we would take it as substituent. Methyl is the substituent on this compound. 3-methyl. Then we can take the name of this compound. 3-methyl. Methyl is the substituent, and on the longest chain, whatever the groups are there, they comes under word root or syntax name. Suppose this is first bond, second bond, third bond, fourth bond, fifth bond, sixth bond. Lowest number, we can take the bond number, and number of carbons are there joined with fourth and fifth carbon. So therefore, that is the, so lowest sum means sum should be there 3, but not 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is not a methyl position, because of lowest sum we have to take. Then if substituents are there more than one, suppose if 2 substituents are there, it may be same or dissimilar position. Then if they are identical substituents, we have to repeat the position along with the ditri, tetra, etc. Then we have to give the name of that organic compound. Say this is numbering 3, 4, 3, 4 dimethyl. Therefore, whenever we are writing the name of the compound, numerals are separated with comma, letter as well as the number connected with hyphen. Then dimethyl. Number of carbons are there in the longest chain, 7 heptane. Then in the same way, when we come across to other compounds, suppose if the compound is there in this way, double bond is there, another one is there, triple bond. Double bond given more priority than triple bond. Therefore, we have to give numbering from this side, 3, 4, 5, but triple bond we should not bend it. Therefore, 5, 6, 7 we can take. Therefore, then here 7 means head. This is first, this is sixth. 6 in 1 in we can write. Therefore, the name of this compound depends on the position of group. Then double and triple bonds are also considered as functional groups. Then multifunctional groups are there, means highest priority goes to COOH, then followed by SO3H, then acid chlorides, amides, acid anhydrides, then aldehydes, ketones, then alcohols. Like the order of priority of functional groups 1 decreases, depends on the priority on the longest chain. Highest priority functional group given as the number without any substituents rule. If dissimilar substituents are there on the longest chain, alphabetical order should be followed. If any side chains are there, suppose if the compound is there in this way, suppose if the compound exists, carbon surrounded with 4 tertiary butyl groups. Then now we have to go with the name of this compound 1, 2, 3, 4, 5. Then second position 2 methyl, fourth position 2 methyl, 2, 2, 4, 4. Tetramethyl. At third position, 2 identical groups are there. They are tertiary, but tertiary not included in IUPAC nomenclature. Iso included, but not tertiary. Then because of they did not give in rules, therefore we should not go 3,3 ditertiary butyl pentane we cannot give. So therefore for that side chain rule we have to go 1, 2. At first position 2 methyls are there. 2 di when we use, second time when we have to go with bis dimethyl, both are same groups. One group when we take 1, 2, longest chain contains inside chain 2 carbons. At first position 2 methyl, but no need of 1, 1 dimethyl because of only 1 carbon is there in the longest chain. One dimethyl, that is called ethyl, the side chain. Therefore, bis dimethyl ethyl, then longest chain contains 5 carbons. Pentane, we have to give the name of this compound. Then, in the same way, these are related to normal chain compounds. Then, in the same way, suppose when we come across to cyclohexane, cyclohexane exists with the CHO, that is cyclohexyl carbaldehyde. Carb nomenclature we have to go on cycloalkanes. Then in the alphabetical order, then this we have to give. CHO we should not start numbering there. Cyclic group we have to separate. Then for 2-bromo cyclohexyl carbaldehydes, but we should not say all because of it. This aldehyde group is dissimilar from the cyclohexyl. Carbaldehyde, carboxy group, carbonyl chloride, carbamide, carb nomenclature we have to go on these compounds. Suppose when we come across to benzene, then benzene nomenclature, suppose one is methyl, another one nitro group is there. Then methyl given more priority than nitro because in alphabetical order, M then followed by N we would give. Therefore, numbering we have to start here. Therefore, 2-nitro methyl with benzene is called toluene. Like this, we have to go with this. Suppose ethyl is there. Toluene is a basically available compound. That is why priority given for methyl. Suppose if it is alphabetical order when we go, so nitro group is there like this. Phenol, that is basically available compound. Ethyl is there, basically not available compound. But ethyl will come first. Therefore, we have to go with numbering in this way. Therefore, 2-nitro ethyl benzene. Then that is the name of these organic compounds. Then, in same way, let me would take about bicyclo compounds. Suppose when we take bicyclo compounds, 2 cyclic groups are joined with common carbons. These 2 are called common carbons. They are called bridge carbons. Then always you have to start numbering from the bridge carbon. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say any groups are there at 7th position, like ethyl group is there. Therefore, 7th ethyl first substitutes. Then these are called bicyclo. Bicyclo means 2 cyclic groups starts with 2 carbons as bridge carbons. Then bicyclo, then in descending order number of carbons we have to keep between these bridge carbons. 4 and 4, 4, 4. In between 2 carbons, no carbons are there. Either comma or dot we can give. 4, 4, 0. Then total 10 carbons show again. Therefore, again we have to follow all the functional groups on the longest chain like normal nomenclature. If a compound exists, 1 cyclic group, that is 1 carbon is a bridge between 2 cyclic groups, then this is called spirocarbon. Spirocarbon compounds when we take, suppose any chlorine is there, Adjacent to spirocarbon, we can give either this place. Again, we have to follow order of priority 1, 2, 3, 4, 5. Therefore, this compound we can give spiro means only one bridge is the bridge carbon exists between two cyclic groups. Therefore, 1 chloro spiro, but there is no carbon on the spirocarbon. Therefore, 2 are there. But in ascending order, number of carbons we are doing. Unfortunately, both are there. Same 2, total 5 carbons show pentane. By this, we have to go this kind of nomenclature about these compounds. So then, there we are observing this kind of nomenclature for bicyclo as well as pyro compounds. Then, in the same way, up to this, let me would discuss from the objective questions. Now, please take your Wiley book and refer objective questions. Then there, please open your Wiley book, everyone. In that, related questions only we would take. Today's topic, today only we have to take up to nomenclature. Tomorrow's topic, isomerism means structural only, stereo means stereo only. Whatever the related questions are there, we would go. Whenever I say, is the question number, please refer that. And if you need important, then write down those answers. Okay? Then, now question number 7. Let me come back to question number 7. The number of quaternary carbon atoms. That is number of tertiary carbons they gave. Tertiary carbon cannot exist there. But here we would take number of, please make it as instead of 3 degree, that you have to make it as 4 degree. That is printing mistake in the textbook itself. Therefore, 2244 tetramethyl pentane. Pentane means 5 carbons we have to take. Here, 2 methyl as well as 2 methyls are there. 1, 2, 3, 4, 5. And here, at second position 2 methyl, fourth position 2 methyl. This carbon when we take, these 2 carbons when we take, here we can identify carbon surrounded by 4 carbons. Therefore, it is quaternary, but not tertiary. But here, carbon surrounded by 4 carbons show quaternary. Then, number of quaternary carbons means how many are there? 2 quaternary carbons. Tertiary, how many are there? Means 0. 0 option itself not there. Therefore, we have to make that question as quaternary carbon. Therefore, 7th B answer is correct. Then, next let me would come back to question number 15, 1-5. Then, how many degrees of unsaturation are there in the following compounds? Compound, if you refer, we can identify very big structure. Please refer everyone. Then, wherever I go on giving about that structure, please refer it. Left side triple bond is there. Here triple bond exists. Then triple bond extension is not given. Then here we can go with like this structure. Then double bond, double bond, double bond. One more cyclic group is there with OH, methyl, and one more cyclic group is there here with one double bond and COOH, acid functional group. And then here we would observe from this place with one double bond, 2 methyl groups. Now double bond equivalent means one triple bond. This is double bond. This is third, fourth, fifth, cyclic 1, fourth, then fifth, sixth. Number of double bond equivalents, how do you calculate? Then double bond equivalents, DU is equal, triple bond means 2. Second position, one double bond, 1, 2, 3, 4. One cyclic, 5, 6, 7. Therefore, this is 1, 2, 3, 4, 5, 6. Cyclic, 7, 8, 9. Then 9 plus 2, that gives 11. Double bond equivalents, you have to make it as 11, but not, they gave answer as B, B not, that is, D is the correct answer. Number of cyclic groups, number of double bonds, and one triple bond is equal to twice the double bonds. Then for that purpose, question number 16 they gave is the referee. If degrees of unsaturation or double bond equivalents, both are same. Then if degrees of unsaturation is 3, then the compound shows one triple bond and one double bond. Now that is 3. Degree of unsaturation if it is 3, one triple bond means equal to double bond equivalents are degrees of unsaturation 2. One double bond shows 1. 2 plus 1, 3 exactly. Then one double bond and 2 rings. One ring is equal to one double bond equivalents. One double bond means 1 plus 2 cyclic show 3. Then third one ring and one double bond. One ring and two double bonds. One ring means one double bond equivalent to double bonds indicate 2. 1 plus 2, 3. Therefore, all these are correct. Therefore, triple bond is equal to 2 double bond equivalents. Therefore, all is the correct answer. That is 16. The answer is correct. Then come back to these all are related to next session questions. Then come back to about question number 28. Little bit about this, why bond lengths are dissimilar. Already I gave in concept. That is canonical or resonance structures of naphthalene. They gave and correct statement about the following. Therefore, 3 structures of naphthalene they gave in 1-2 structures, 1-2 position, 2-3 position. In every structure, 1-2 position shows double bond and 2-3 position show triple bond. From this, we would learn then all delocalization of pi electron from one cycle to another cycle is slightly deviates. Therefore, C12 shows 1.36 in naphthalene. Whenever we take naphthalene, then here one cyclic delocalization and another cyclic delocalization slightly deviates. Therefore, suppose if it is 1, 2, 3, C1 to C2, bond length we would observe 1.36 angstrom units, slightly lesser than benzene delocalization 1.39 angstrom units. C23 it shows 1.40 angstrom. Slight deviation is there in case of naphthalene. Therefore, that we would observe C1 C2 bond shorter than C2 C3 bond. That is naphthalene. It is possible. Therefore, second answer or B option is correct. Okay. Then next, let me would come back to question number in this page. No other related question we would observe. Then question number okay. Now let me would come back to question number 42. Question number 42 when we come across, let we would see about question number 42. Question number 42 when we take, then we will see about it. Here structures are provided. Which of the following structures represent 2-bromo 6 isopropyl? 2-bromo 6 isopropyl. Isopropyl means 2 methyl groups extended structure. 4 methyl 3 in 1 pole. That is the structure when we take, we could observe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then here one OH group is there. Then suppose we would take it as bromine, 4th position, methyl with a double bond. 4th structure we are drawing here. It's the isopropyl. Now, numbering if you do, because the OH group is the more priority group than bromine or double bond. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The given compound, then here they give 2-bromo, second position bromo, 6 isopropyl, this is the isopropyl group, then 4 methyl, this is methyl group, 3 in, therefore third and fourth carbon in that least number is bond Number we would take 3 in and 1 ol. That is first position occupied with 1 mole. Therefore, 1 ol means alcohol. Therefore, 42, the answer exactly suited the given name and its structure. Then, next 45, the decreasing order of electronegativity of hybrid orbitals is electronegativity of carbon depends on S character in hybrid orbital. Say, suppose if it is sp hybridization, S character is there 50%. If it is a sp2 hybridization, 33.3% S character is there. If it is sp3 hybridization, only 25% S character exists in sp3. More S character show higher electronegative, then with the decreasing of S character, electronegativity decreases. Therefore, among those, we would take 43. A answer is correct. More S character show more electronegativity. Therefore, Sp greater than Sp2 greater than Sp3 we have to take for the electronegativity of carbons. 43, A answer. Then question number 44. Go through this. Refer question number 44. Are you followed? Because of more S character show more electronegativity. Then let me would come back to question number, that is question number 44. The IUPAC name of the following compounds. Say this is benzene ring. Here it attaches with CO means C double bond. NH. This is amide group with respect to this compound. Then again attaching to another benzene ring. Then with here we would observe COOH and it is NO2. Then COOH gets highest priority. Therefore 1, 2, 3, 4. This is amide group. Then here we would observe. Then the IUPAC name is option A, 4-benzyl amino. This is called a benzyl amino group on this longest chain. Because COOH gets more priority than amide, then this is taken and taking as substituent. Therefore, at fourth position, 4-benzyl amino. Benzyl, this is benzyl, this is amino. Benzyl amino, 2-nitro benzoic acid. This compound is called benzoic acid. That is the name of that compound we will take. That is option A is exactly correct. Then next we would come back to question number 47. Question number 47. What is the simplest alkane? That is the one that with smallest molecular weight, which possess primary, secondary, and tertiary carbons. Number of carbons should be there lesser. Then there we would observe this is the structure we would take for this compound. Here we would observe primary 3, secondary 1, tertiary 1 carbon. Carbon attaches with 3 carbon shows tertiary. Then possess primary, secondary, and tertiary. All those are there with the isopentane. Therefore, then 3-methyl propane won't be there like this 3. 2-methyl pentane, that is 6 carbons, higher molar mass. 3-methyl pentane is also there, higher molar mass. C and D have higher molar mass. The lowest molar mass is there with all the primary, secondary, and tertiary carbons. That is B answer is correct. This is the structure we would take for isopentane, or that also we would take 2-methyl butane. Numbering we have to give 1, 2, 3, 4. That is the lowest sum we are following. Therefore, 2-methyl pentane. That is the name of the compound. B option is exactly correct. Then next, let we will come back to question number next page. That is 59. Question number 59. Please refer wherever it may be, the same page or other page. Question number 59. Then removal of a hydride ion from methane molecule gives, I'm sorry, that cannot come because of that carbon ion, carbocations. One more glass we would take. Then question number 60. IUPAC name of 4. That is question number 60. Please refer this question. 4 isopropyl metaxylene, that is benzene. We can take circle or 3D, alternate position double bonds, isopropyl, that is, what do you say, metaxylene. Two methyl groups are there on the benzene shows xylene. If all both the methyl groups are there adjacent position ortho, the next third, that is, these are ortho positions, these are meta positions, this is para position. In IUPAC norm, that is common nomenclature. In IUPAC nomenclature, we have to represent with numerals. Therefore, then there we would observe this is called 1, 2, 3, 4. 1, 2, 3, that is 1, 2, 3, 4, 5, 6. Methyl given more priority than isopropyl. Then we have to go with this. Then there we would observe then 4 isopropyl. This is 2 methyl extended group is called 4 isopropyl. 4 isopropyl. 2, 4 dimethyl benzene. This is called that is 1 isopropyl. I'm sorry. Numbering we have to start with the isopropyl. I'm sorry. Isopropyl given more priority. 1, 2, 3, 4. Because of lowest sum, it cannot satisfy. Because of lowest sum, we have to consider. Therefore, isopropyl given more priority than methyl. Therefore, 1, 2, 3, 4, 5, 6. Isopropyl given more priority than methyl in case of this compound. Suppose nitro group is there, methyl given more priority. Fluorine is there, methyl given more priority. Both the halogens are there, alphabetical order we have to follow on benzene nomenclature. Then this is the 1 isopropyl 2,4 dimethyl benzene. 2,4 dimethyl benzene that we would take with option 1. Option 1 is exactly correct among those. Then next 61, question number 61 when we come across. Then double bond O, OH. Then followed by one amino group is there. Solid wedge. That is 3D structure of the given compound. Double bond ONH. Then extension of its structure. Double bond O, OCH3. Then it also connected to the benzene ring. Then now we will take, then here how many number of functional groups? Number of functional groups, do you mean this is one acid group, this is amide group, then amino group, and ester group. Then here we can identify ester group and phenyl also another. Phenyl also considered as one of the functional group. Therefore, 1, 2, 3, 4, 5 we can take. Therefore, that number phenyl generally it won't get into the same double bond or phenyls are considered as functional groups. Therefore, 5 is the answer we would take for 61. That is C option is correct. Then now we would come back to 64. Question number 64. Now, 64, question number 64 when we come across, question number 64, the IUPAC name of the compound, nitrogen surrounded by 3 ethyl groups are there. CH2, CH3. Then the name of this compound, on the nitrogen, any alkyl groups are there, we have to start with the longest carbon chain of amine with the smallest substituent alkyl groups. All are same here. And then that is why we would give smallest alkyl groups we would take as substituents, longest chain we would take it as amine derivative. NN2-ethyl indicate NN diethyl, then 2 carbons extension of amine that shows ethanamine. So the name of this compound exactly suits with the C option. Then next let we would come back to 66. Compound with structural formula RCN and RNC. This is exactly an isomerism we would get that is related to functional isomerism later we will see. Then identify the number of sp3 hybridized carbon. This we will get in nomenclature part only. Identify the number of sp3 hybridized carbon atoms in the given compound. sp3 hybridized carbons. That we will take the question number 67. When we come across to this compound, then 2-methyl, I will separate these 2-methyl groups. They gave CH3 twice, instead of that, I'll separate it, and then double bond CH, another carbon with 3-methyl groups they gave, separated. Now, we need sp3 hybridized carbon. It should not attach with double bond or triple bond. This is sp3. sp3, these are attached with the double bond, and that is triple bond, sp3, sp3, sp3. Then there we can identify how many, identify the number of sp3 hybridized carbon atoms in the given compound. sp3 hybridized do you mean 1, 2, 3, 4, 5, exactly this is also 6 should be there, but there is no, that is only, okay, 2-methyl groups on the carbon center. I'm sorry, not 3-methyl groups are there. CH, another carbon with 2-methyl groups are provided. But means that is exactly, formula is incorrect. But hydrogen we should take. Then there we would observe this is sp3, 1, 2, 3, 4, 5 we should get. But this carbon they missed in the given compound, therefore there exactly they did not give proper structure. So that is why this also we have to take 1, 2, 3, 4, 5. So therefore 5 is the answer but not 4. Okay, then that is about 68 question number within 5 minutes. Okay, then 69, decreasing order of CC bond length is, decreasing order of CC bond length do you mean, then always we would take decreasing order of bond length. That always we would take order of bond length means, suppose if we take C6H12, that is cyclohexane, then there we could observe in cyclohexane 1.54 angstrom units. Then that is third one we would take it as benzene. All bond lengths are equivalent to 1.39 angstrom units, decreasing order. Then next we would take with ethylene, that is CH2 double bond CH2. Then here you have 1.34 angstrom units. Then first one is there with acetylene. C2H2 means CH triple bond CH 1.20 angstrom units. Therefore, the order we would observe with option A is the correct answer. Okay, option A, decreasing order we will identify. Therefore, highest bond length in cyclohexane and lowest bond length observe in case of ethylene. Then 70, name the family to which each belong. That is related to, first one is their acid group, second one is their amine group, third one is there with alcohol. Therefore, option we would go with acid, amine, alcohol. Therefore, option we would observe about 70, question number 70, C answer is correct. 71, the structural formula of cyclohexyl alcohol. Cyclohexyl alcohol, do you mean only cyclohexane? On that OH group is there, then it is called cyclohexyl alcohol. Therefore, that structure we would observe in 71, A option. Then 72, name the following substance. Then here we would take benzene derivative, that is related to COOH group. Then second position chlorine given, and fourth position ethyl group given. Then numbering we have to start with highest priority for COOH 1, 2, 3, 4, 5, 6. Then here alphabetical highest priority goes to COOH. Therefore 1, 2, 3, 4, 5, 6 we have to give. Therefore 2 chloro, 4 ethyl, 2 chloro, 4 ethyl benzoic acid. That is D answer is exactly correct. Exactly correct. D answer. Therefore 72 the answer. Then 73.
Sir, it's time.
Okay, no, right. Then 72 finish. Then 73 onwards, we will take in the next class. Right? Thank you.